Hey everyone, I'm a small lizard, and continuing for PnC, we're going to be looking at the idea of complement. So what are complements? So the idea of complements basically stems from the fact that if let's say, if you remember in the introductory video, we have the sum of all probabilities of all outcomes equals to 1, right? And the ideal complement is actually using this particular identity right here, where if, for example, we have outcome A and outcome B, we can find the probability of A by taking 1 minus probability of B, right? Because if it's not B, then it must be A. So 1 minus B is something like not B, and therefore equals to A. Of course, if there are more outcomes, let's say for A, B, C, then we have PA equals to 1 minus PB minus 1 minus another PC. All right, so if there are 3 different outcomes, then that would be it. So over here is neither B nor C. So this is the idea of complement. And of course, it's not just restricted to probability. We can also look at the number of cases as well. So let's say number of cases. Let's say it's either case A or case B. Then we have total number of cases equals to case A plus case B. Then we can find number of cases of A equals to the total minus case B. Now this only works if it is either B or A strictly. So it can either only be A or only be B. Of course, in the long run, in more context, you realize that it can be A or B, and you can be both A and B at the same time. So that is where we need to be careful when it comes to looking at complement. All right, so likewise, these 3 outcomes right here, either one outcome only. So you cannot have both A and B happening together. You cannot have B and C happening together, nor A and C happening together. All right, so either one outcome over here, either B or A strictly. All right, so we're going to look at how we can use such ideas in 2 different examples. The first one being right here. The group is planning to go out for lunch, having either steamboat or barbecue. If it is raining, there is a 4/5 chance they will have steamboat. If it is sunny, there will be a 3/5 chance they will have barbecue. Then given any given day, there's 25% chance of rain. Find the probability that they have a steamboat for lunch. All right, so first up, we have the condition, right? If it's raining, it's different probability. If it's sunny, it's different probability. So it's good for us to at least write down what's the probability of it raining. We know that there's a 25% chance of rain, so we have 25%, so 0.25 or 1/4. For sunny, right, because it's either sunny or raining, so there are only 2 outcomes, it has to be 1 minus 0.25, 0.75. If it's not raining, it is sunny. Likewise, if it's not sunny, it is rainy. All right, we are assuming that there's only these 2 states of weather. All right, so then again, now we look at the group having the options for lunch is either steamboat or barbecue. If it's not barbecue, it is steamboat. If it's not steamboat, it is barbecue. All right, so now that we know that we want to find the probability of steamboat and we have the 2 weather conditions, rainy and sunny, we can now check the probability of having steamboat for lunch. Now let's look at the rainy condition. So rainy is 0.25 times. If it's raining, the question said that there's a 4/5 chance to have steamboat, so 4/5. Sunny is 0.75. Now, what did the question say? 3/5 chance to have barbecue if it's sunny. So since 3/5 chance of having barbecue, then there'll be 1 minus 3/5 chance to have steamboat. So 2/5 chance. So 0.25 times 4/5 is simply 0.2 or 1/5. 3/4 of 2/5 is simply 0.3. All right, because 3/4 times 0.4, well, 0.3. All right, it just so happens that there's an equal chance of having steamboat or barbecue at any given day, because the probability of steamboat for any given day is 0.5, which means that the probability of having barbecue on any given day is also 0.5. If let's say we have to tweak the value and we get probability equals to, let's say 0.4 instead for steamboat, then we have 0.6 chance of eating barbecue. Alright, so that is the idea right here when we look at complement when all the outcomes are given. Now in the second example, we're gonna have a bit of imagination or a bit of analysis for us to do, because the obvious outcomes are, well, we need to come up with these obvious outcomes. Alright, now a group consisting of 3 boys and 5 girls stand in a row. Find the number of different arrangements possible if Tom and Jerry are separated. So you can really think about this, right? We know that we're going to arrange them in a row and we want Tom and Jerry to be separated. And let's say you try to really think of cases. Let's say Tom is right here, then you notice that Jerry has 1, 2, 3, 4, 5, 6 spots to go to. But if Tom is not at the edge, let's say somewhere in, let's say second seat, third seat, fourth seat, fifth seat, sixth seat, seventh seat, you notice that, hey, Jerry has only 5 spots to go. So there's this difference that you need to cater to. And that's not something we want to try to figure out. Alright? So of course you can actually kind of simplify it. You can just consider Tom here, and then you just take times 2 factorial, but that wouldn't really help that much. Alright? So what else can we do? Now, you can really think of it this way. If Tom and Jerry are separated, what's the alternative? Them being together, right? So Tom plus Jerry together, or Tom and Jerry separated. Is there any other outcomes? No, right? They're either together or not. Very simple, just like any relationship. All right. So what we can do is because we want to find the different arrangements, we can take total minus Tom and Jerry together to give us separated. All right. So very simple. What's the total number of cases? 8 factorial. What's the cases of them being together? 7 factorial, because we're going to group Tom and Jerry together, and then we have 6 of the remaining people for a total of 7 items. This simply gives us 8 factorial minus 7 factorial, which is 7 factorial times 7, 35280. Alright, why 7 factorial times 7? Because I can factorize 7 factorial, I get 8 minus 1. Right, so this is the first part, the first question. Now the second question. A bag consists of 5 red and 5 blue candies. If 5 candies are chosen for replacement, what is the probability that at least 1 red candy is chosen? And you do realize that it's going to be a pain to list down the different probabilities, right? Because you can have 1 red and then 4 blue, and then 2 red and 3 blue, and then 3 red, 2 blue, and so on and so forth. Not only that, because you're going to draw the candies almost sort of like one by one, you think about the arrangement of how it's being ordered. Arrangement of how the candies are being drawn. So in this case, you talk about 5 factorial divided by 4 factorial. Over here, you talk about 5 factorial divided by 2 factorial divided by 3 factorial. And it's going to take quite a long time. All right. Now, in some cases, you really have to do that. And you have not much time. You have no other way. So suck it up, right? But in this case, you realize that, hey, we can use the complement method. How? Because the idea is, if we have at least 1 red candy chosen, what's the alternative? No red candy chosen. Yeah, and that is much simpler, right? And because we're looking at probability, we have to count the cases. We just need to take 1 minus the probability that 0 red candies are chosen, which is the same as 1 minus probability of 5 blue candies chosen. And the probability of 5 blue candies chosen are very simple. Because there's only one way to arrange 5 blue candies, B, 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 B. So we just need to take 5 over 10 times 4 over 9 times 3 over 8, so on and so forth. A very simple way to do it is combine everything together. 5 times 4 times 3 times 2 times 1, denominator 10 times 9 times 8 times 7 times 6. And this is way simpler in calculating, alright? So we have 5 factorial on top, below we have 10 times 9 times 8 times 7, which is the same as 10 factorial divided by 5 factorial. And this gives us 1 minus 1 over 252, and very simply 251 over 252. Alright, so as you can see, the complement method is very useful, especially when it is very clear cut, where it's either 1 red candy or 0 red candies. Obviously, when you look at, let's say, higher order of questions, you might need to be a bit more careful. Alright, so we'll get to that in the future videos when we talk about the idea of union and intersection, and you then realize that sometimes it's not. Using the complement method has some pitfalls as well. Alright, otherwise, take your time with this, get used to using the complement method and the other grouping and slotting, and I'll see you guys in the next video.